Okay, so in dynamic loading, and to estimate accurately the strength of failure and fatigue and dynamic loading, you need to apply stress concentration effects if there are stress concentration effects. You know that there will be stress concentration if there's change in dimensions, any change in surface, any groove, change in diameter, any hole, any notches, that will give you stress concentration. And if you have these situations, then you need to include stress concentration for fatigue stress concentration factor, Kf. This is capital K, F. This is different than the modification factors for endurance limit. To calculate this fatigue stress concentration factor, you need two factors. You need to find Kt, which is a theoretical stress concentration factor. This, you can go to appendix A15. There are many figures that can be used to find theoretical stress concentration Kt for different situations and different loading type. Okay, and the other one is the notch sensitivity Q. So these two, Kt and Q, would be used to find Kf. This is the formula here. CKF, we have Q and we have Kt. Let me go back to the previous slide. Okay, so Kt, as I said, comes from appendix A15, depending on the loading type and the geometry of the machine element. The notch sensitivity Q can be calculated using the formula, or you can also use this figure. So if you have bending or axial loading, you can use this figure, figure 620. In this figure, you can see that we have notch radius. So this horizontal axis gives you notch radius in millimeter. So this is half a millimeter, this is 1 millimeter, 1.5, 2, and so on. And the curves here, they give you the ultimate strength. This is ultimate strength. For this curve, we have ultimate strength of 1.4, and let's say this curve is ultimate strength of 0.4, this curve ultimate strength 0.7, and so on. So if you have a material with ultimate strength of, let's say, 800 megapascal, 800 megapascal ultimate strength, that means the curve for this material will be between the 0.7 and 1. This is 700 megapascal and this is 1000 megapascal. Okay, the numbers here are in gigapascal, so this is 0.7 and 0.1, and 0.8 will be somewhere, let's say like this. So if the notch radius is 2 millimeter is here, that means the intersection is this point. This is 2 millimeter point, and this is 800 megapascal radius. So let's say R is 2 millimeter. Okay, so for R 2 millimeter and ultimate strength 800 megapascal, we can read Q. So Q will be, this is 0.8 and this is 1, here we have 0.9, so it's 0.85. This is just an example, a rough example of how you find notch sensitivity from this curve. Okay, so this curve can be used for any bending or axial load. If you have shear, then you must use this curve. Exactly the same procedure, The only difference is that you can see this S here. So this is notch sensitivity for shear, theoretical stress concentration for shear, and fatigue stress concentration factor for shear. The same thing, you're going to need notch radius, you're going to need ultimate strength, and you need to match. For example, if we have 400 megapascal, which is this curve, this is the 400 megapascal, so this is the curve, and 3 notch radius of 3 millimeter. So this is the intersection here, 3 millimeter and 400 megapascal. You go and read Q. Okay? Okay, this is an example of how to calculate KF. Okay, you need type of load. Here we have bending. We have the ultimate strength. Okay, so this is a fillet radius here. Fillet radius is this one, the notch radius. The notch radius. Okay, and you can see here we have change in diameter, 32 millimeter and 38 millimeters. So this is a rod connecting two different diameters. So here we have stress concentration. So because we have a change in diameter from 32 to 38, notch radius or fillet radius is R, 3 millimeter in this case. So we have stress concentration at these points. We must calculate stress concentration factor Kf, and this Kf will be multiplied by the stresses that we have. To find Kf, you need Q and you need Kt. So you need to go to the appendices to find Kt, and you need to go to the Kt is from this figure, appendix A15, figure number 9. You can find Kt and Q from the previous curves. Okay. Now that stress concentration will be added to your stress. So instead of let's see how much was the stress. Instead of 260 megapascal, because of that change in diameter, we have stress concentration of 1.5. So my stress is 403. Okay. In this example, we also calculate number of cycles for different stresses. Okay. The next example is to calculate endurance, or to estimate the value of endurance limit. So this endurance limit, you need to add size factor or surface factor. Size factor doesn't have an effect. Load factor, temperature, reliability, and so on. So the size factor, the surface factor comes just from name of the material. You see here it says hot rolled. Okay, from hot rolled you can find can go to the table for for surface factor and calculate surface factor. Also here we have diameter and we have type of load. Type of load is axial. So axial load means size factor doesn't have an effect. Size factor will be 1. Axial load will also give you a value for load factor. Okay, so just from the load, from the name of the material, you can identify 3 factors: surface factor, size factor, and load factor. Okay, and if temperature is given, you can calculate temperature factor. If reliability is given, you can calculate reliability factor. If they are not given, then they just equal to 1 and they don't have an effect. Okay, so in this example, endurance limit was 165, that's 0.5 of ultimate strength. And when we added all the factors, it changed to 110.